So in this video, we're going to look at plugging values into a formula. And we kind of have already been doing this in the last couple sections, but we're going to kind of look at it a little bit deeper, really just looking at the formula and kind of understanding by example or description what's going on. So they ask us to kind of examine some formulas, and then we're going to kind of use that to make some predictions. So they give us an example. Let's say your bank account balance is represented by A equals 850 minus 50T. So you may recall from what we've done before that we said A represents your bank balance or account balance, and T represents the time in months. So how much money will be in the account in 8 months? Well, if I plug in 8 into the formula, 8 times 50 is 400. Subtract that from 850, and I'm going to get 450 is my balance. Okay, so when you travel outside Oregon, most places have sales tax. Bummer. The total cost of what you buy is related to the tax rate as a decimal, and the pre-tax item and the pre-tax price of the items you are buying. We could use the formula C equals 1 plus T times P. Let's identify the quantities in this formula and which letter you think is used in each quantity or for each quantity. Okay, so based on what we're talking about, it makes sense that we're talking about our total cost here. So I'm going to label capital C as the total cost. All right. Then we have this idea that the total cost of what you buy is related to the tax rate as a decimal and the pre-tax price of the items you are buying. So, I see T there, and I'm kind of thinking that's probably the tax rate. The reason is it is labeled T, but you'll notice that they added the 1 to T. To me, that's a big tip off that they're talking about a percent. And T is a tax rate. It is like it's a decimal, but it's a decimal percent. So most places, like, they have a 7% sales tax rate, right? Most taxes are written as percents. So the fact that they added it to 1, that's telling me that they're taking the percent that they want to increase the price by and adding it to 100%. So we're going to pay the original cost plus an additional little percent tax. So T for tax rate, plus it makes sense, it's T. So P then is kind of left over to be the pre-tax price. All right, it makes sense based on the way they labeled everything. Cost, tax rate, price. All right. Okay, so what is the total cost? If the sales tax rate is 9%, which means the decimal would be 0.09, and the pre-tax price of the items you're buying are $50. Okay, so we're going to find, using this formula, what that comes out to. So C equals 1 plus, okay, so T is the tax rate, which is 0.09. So I'm going to write that in for T. I'm going to close the parentheses and then times P, which is the pre-tax item, or $50. Okay, so if I want to figure this out, I'm going to use order of operations. And we'll see that again later. But order of operations say I need to start with what's inside the parentheses. I need to first add those two. That's why there's a parentheses there. So 1 plus 0.09 is just 1.09. And then I'm going to times that by the 50. So grabbing my calculator, 1.09 times 50 comes out to 54.5. There's my cost. That's how much it's total going to cost me. $54.50 if the tax rate is 9%. All right, let's look at another one. The total cost in cents for running an electrical device can be found if you know the number of watts in the device and the amount of time you've used the device and the cost of your electricity. All right, so they give us a formula and we're going to try to identify everything in the formula. It's a very large formula. I don't know why they have it so big. That's fine. Let's look at it. Okay, so total cost, again, I'm thinking that's the big capital C on the outside. For running an electrical device that can be found if you know the number of watts of the device. Okay, well, I see a W, so I'm thinking that's watts. T, the amount of time in hours. Yep, there we go. So T is hours. And that little c is going to probably be the cost of electricity. So lowercase c is cost of electricity. So I kind of intentionally used lower cases when I labeled each of these, just so I could tell the difference between the capital C and the lowercase c. All right, so there we go. What is the total cost of charging your cell phone? I love this. This is so good. That's something we all understand. If you have a 12-watt charger, it takes an hour to fully charge, and the cost of your electricity is 8 cents for each kilowatt hour. Ugh. Okay, so kilowatt hour, that's kind of annoying. Oh, never mind. Actually, in the formula, it says it's kilowatt hour. Okay, cool. So I don't have to worry about the fact that one's watts and one's kilowatts. The formula takes that into account for me. Okay, fabulous. Good deal. So here's what we're going to do. We're going to plug everything in. So what I don't know is the total cost. That's what I'm trying to find. So capital C equals. Okay, so the watts is 12 watts times time, which is 1 hour, and time is an hour. So 1 times cents for each kilowatt hour. So I think we're going to actually plug in 8. I don't think we have to plug in 0.08. I think we just plug in 8, since C is in cost of electricity, but that cost is measured in cents per kilowatt hour. Wow. Kilowatt hour. That unit of measurement is very funny to say. So this would be, here, let me say it like this, time, but it's in hours. Okay, there we go. Just wanted to clarify that. Okay, divided by 1,000. Okay, so if I want to figure this out, I need to start by multiplying the numerator. So 12 times 1 times 8, that's going to come out to 96. And then 96 divided by 1,000 is going to be 0.096. Okay, so if we're talking about money, it would make sense to round to the hundredths place, because, you know, 2 decimals after for money. So if I rounded that, it's going to actually round to 10. So this would be 10 cents. So this is literally going to cost 10 cents to charge this. Nice. I forgot and left my heater on all night, 9 hours. The heater is 1,500 watt unit. If electricity is 8 cents per hour, how much is that going to cost? Okay, so still using this formula. C equals, this time, 1,500 watt heater times 9 hours. Wow, it's a long sleep. 8 cents per hour. I guess I shouldn't judge. Some people need more sleep than others. And then let's start by multiplying the numerator. So 1,500, I'm going to grab my calculator, times 9 times 8. So that is, ooh, big number. 108,000 over 1,000. And that's going to come out to 108. Yikes. $108 for that. Yikes. That's expensive. There you go. That's the cost of leaving that heater on all night. Okay. Relationship 3. The interquartile range, which is a single quantity in the first quartile, can be measured to find the lower fence for a set of data. Now, what's funny is this is actually a statistics thing. So if anybody's moving into statistics, like in the future, they know they're going to eventually take statistics. This is a formula that you use in statistics, but it doesn't really make sense right now. And that's okay. I don't need it to make sense. I just need to know what the formula is so that I can use it. The lower fence is used to determine if any small values are outliers in the data set. So we could use this formula. So let's identify things. So LF is lower fence, I'm pretty sure. Lower fence, what they're calling the lower fence. Q is the first quartile. And then IQR is what they've called this interquartile range. All right. So what is the lower fence for a set of data where the first quartile is, oops, sorry, it's not scooching up. First quartile is 12 gigatons and the interquartile range is 5 gigatons. Okay, well, let's see. So LF equals, okay, first quartile is 12 minus 1.5. Such a sad looking 5, I'm sorry, 1.5 times 5. Okay. For the interquartile range. So first thing I need to do is the 1.5 times 5, which comes out to 7.5. And then 12 minus 7.5 is 4.5. Cool. So there's the lower fence. All right. Evaluating exponent on your calculator. So they were super cool and tried to show you on a variety of different calculators which button is referred to for the exponent button. It could be X to like a blank symbol, like a square. It could be this, what's called the caret symbol. That's the second one. They call that the caret symbol. It could be X to the Y. It could be Y to the X. Those are the most common versions for exponents on the calculator. And if you have your calculator, use it to find 2 to the 4th and make sure you come up with 16. All right, make sure you figure out how to use the exponent button, because otherwise this next problem is going to be more difficult if you don't know how to use the exponent button. And if you have trouble with that, let me know. I just realized that there's a bit of an error on here. So on mine, I'll try to erase this before I post it up on Canvas. So just ignore that. That's a typo. The compound interest formula is used to find the future future value or amount of an investment. The principal is the amount of money invested. The annual interest rate is written as a decimal. The future value also depends on the number of years of interest. So let's identify things. Okay, so they call future value the amount. So A is probably the amount / future value. So it's the idea you're investing for something you're going to get in the future. All right. Principal is the actual amount of money you invest now. So P is principal, which is really the investment, how much you're going to put away. Annual interest rate is written as a decimal. I bet that's R. Annual interest rate. And future value depends on number of years. So there's time, T. Time in years. All right. What is the future value of an investment at 10,000? Sorry, of 10,000 at 3% annually for 4 years. So P then is our investment of 10,000 times 1 plus, okay, so 3%, we need to convert that to a decimal, which means I'm going to move the decimal 2 places to the right. Sorry, 2 places to the left, which will be 0.03 if I write that as a decimal. So this will be 0.03. And then 4 years, that's going to be an exponent. So it's actually an exponent, and we have to use an exponent button to do this. So first thing I'm going to do, like I said earlier, we got to start with those parentheses. So we're going to do 1 plus 0.03, which is just 1.03, raised to the 4. And we need to do the exponent next. So raising it to the 4, we're going to do 1.03. And then in your calculator, you put 1.03, hit the exponent button, and then do 4, and then enter. And you should get a horrible decimal. I'll write down what I've got. I ended up with 1.1 125508881. That's what my calculator gave me. Maybe it gave me more or less than your calculator, but there you go. Terrible decimal. Now, notice that the 10,000 is next to the parentheses. So that means this is representing a multiplication. Here, I'll put a dot there for multiplication. Or if you want to put a times symbol, you can put a times symbol. Or if you want to keep the parenthesis, just so you know it's multiplying, you could keep the parenthesis from multiplying, whichever feels most comfortable to you. Go ahead and use whichever one you'd like. We've been using the dot for these, so I'll go ahead and use the dot for timesing. Okay, so we're going to times this number in my calculator. I'm going to actually not touch it. I'm going to leave it in my calculator and literally hit times 10,000. That way it takes the decimal for me and I don't have to retype it back out. And I get 11255.0881, which as an amount or money amount would be $11,255. And then I should go ahead and round this to the hundredths place. So that's going to round to 0.09. Okay, so the last thing they kind of wanted to mention is that we're using order of operations, and we hadn't really talked about it, so they want to kind of talk about it for a second. So parentheses comes first for order of operations. First is parentheses, then is exponents. Here, I'll use a different color. Exponents are next. I selected it, but it hadn't updated. I'm sorry. Exponents, there we go. And then here we'll use purple this time. Then after exponents, we do multiplying and dividing. Oops. Okay, I knew it was going to jump. I'm so sorry, guys. Wow, it jumped so far. It jumped all the way back into the last section. I'm so sorry. Whew. That just really got mad at me. Okay, multiplication and division. And then lastly is addition and subtraction. And let's see. Yeah, I'm doing it. I'm committed. Here, we'll use pink this time. There we go. So those are the 4 steps for order of operations. We start with parentheses, then exponents, then multiplying and dividing, then addition. Okay, cool. So then they're like, okay, now that you know that that's the order of operations, let's identify formulas that use parentheses. So this last formula had parentheses, and so did the first formula. In both of those cases, we use parentheses. Exponents. Well, there's actually only one formula we use that had exponents. That was the last formula. So this one. Multiplying and dividing. Well, actually, all of them did multiplying and dividing, right? Here we multiplied the P times that parenthesis. Here we multiplied 1.5. Here we multiplied all the numerator and divided. And then here we multiplied the parenthesis by P. So in every single one, we had multiplication and only one of them we had division. That was the second one. And then addition and subtraction, let's see. So actually the last one had an addition. This one had a subtraction, but the second one here didn't have either. And the first one had an addition. So only those had addition or subtraction. 2 of them had addition, 1 had subtraction. And there you go, just kind of a refresher on order of operations. They do mention for both addition and subtraction, it's left to right. Left to right. That's important. Always goes left to right when you're doing multiplying and dividing or adding and subtracting. And there you go.